Yo, 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 yo. All right, folks. Factoring polynomials. So, first thing we have to know is what the greatest common factor is. So, greatest common factor, a lot of us have known what that is, like when we're reducing fractions and whatnot. But now it has to do with the largest positive integer and the common variable with the common degree. That divides evenly into all terms. So, for example, if I have 7x squared plus 7x. So my common factor, greatest common factor is what can be divided evenly, what's the largest positive integer can be divided by both of the numbers in front, the coefficients, which would be 7. Okay, because I can divide 7 by 7, I can divide 7 by 7. But then it's also the common variable with the common degree. So I cannot divide these both by x squared because this does not have a square. This only has a degree of 1. So the common degree I can factor out of both of these is 7x. So the greatest common factor is 7x for this particular situation. So what we're doing is we're going to be determining what is just the greatest common factor for each term. So first I look at the coefficients, the numbers. What is the greatest common factor between 12, 8, and 6? So one way is to look at the factors of the smaller number. So I have 6, 3, 2, and 1. Can I divide everything by 6 evenly? No, I cannot divide 8 by 6. Can I divide everything by 3 evenly? No. What about 2? And 2, yes, I can. So the greatest common factor for the coefficient is 2. Now I look at the common variable with the lowest degree that they have in common. Well, that would be x to the third, because I can factor out an x to the third to the fourth degree, and I can also do it with the fifth degree. So I can factor out 2x cubed from all three of these values. Now, when we say factor out, what we're talking about is dividing. Okay, so we are talking about dividing out we're talking about dividing each one of these by this value, but then we pull it out to the outside. It's almost like distributive property backwards. So if I were to factor 2x to the third power out of all this, what I'm doing is I'm doing 12x to the fifth power divided by 2x to the third. Well, 12x to the fifth power, 12 divided by 2 is 6. X to the fifth divided by x to the third, when we factor, we subtract the exponents. That'd be 6x squared. 8 divided by 2 is 4. 4 minus 3 is 1, so it'd be 4x. And then 6 divided by negative 6 divided by 2 would be negative 3. X to the third divided by x to the third is 0. And I'm done. So this is if I actually factored it out, which I know it doesn't say to do right now, but I just want to show you what we're doing. If I were to factor out the greatest common factor, this would be my final answer. So it's doing the distributive property backwards. So what we want to do is we want to factor out our greatest common factor from this polynomial. So first we look at the coefficients. I have 6, 4, and 10. Well, the only common value that they have is 2. And so my coefficient that I'm going to factor out is 2. Now I got to look at my variables. So I have a to the fifth, a squared, a to the fourth. Well, the lowest a degree is 2. Now I look at my d values. 2, 2, 3. Lowest one is 2. So this is my greatest common factor. And what I'm going to do is I'm going to divide all of these pieces by that. So if you need to, you can show this division to kind of help you stay organized. I can divide everything like so, because that's what I'm doing. But then I'm bringing that to the outside over here. Okay, negative 6 divided by 2 is negative 3. 5 minus 2 is 3. 2 minus 2 is 0. So that cancels out. That's done. Plus 2 a's cancel out and the d's cancel out. And then 10 divided by 2 is negative 5. A to the fourth divided by a squared is a squared, because 4 minus 2 is 2. And then 3 minus 1 is 1. And the way I can check is I could distribute this to see if I get the exact same thing. Okay, so it's distributive property backwards. This would be my final answer after I factored out the greatest common factor from this polynomial. Okay, so go ahead and try these two on your own. Pause the video, see how you do, and that's that. So pause it, try it, see what happens. So for this one, my greatest factor is just 3. So that's going to be 5x squared plus 6. Okay, because this doesn't have any x value, so I can't factor out an x. I'm done. That's what it's going to look like after having a 3 on the after factoring out a 3. This one right here, my greatest common factor is 6y squared. So that's going to give me negative 3y squared plus y, and that's going to give me plus 4. And I am done. Okay, again, 2 more to try out. This one's going to have 2 variables, so that's okay. But try it out and see how you do. Find your greatest common factor, factor them out, rewrite your answers. Okay, so this one, my greatest common factor is 4x. So that's going to give me 3x to the third minus 4x squared plus 2x minus 7. So here, so look, I'm looking at my integers. My greatest common factor is 2. X's, I have 1 x in common, so that's 2x, y. So that's what I'm dividing by. Well, when I divide by that, that's going to leave me with 2 divided by 2 is just 1. X squared divided by x is x, and that's it. Y divided by y cancels out. Minus, that's just going to be minus 2, and then this is going to give me plus 3y. Okay, so for factoring, sometimes what we're going to have to do is we're going to have to solve word problems where it's going to require us to factor. So Alani is in charge of marketing for a travel company. She's designing a brochure that will have 6 photos. So 1, 2, 3, 4, 5, 6. The photos can be arranged on the page and on the page in a number of ways. There are 2 main square photos which have a length of x on each side. So these are all x. There are 4 narrow photos that are each 1 inch by x inches. So I know that this is x and I know this is 1. This is x, 1, x, 1. What is the total area of the photos? So first what we're going to do is we are going to find the area just of one of these little photos. So let's see here. For one of the small rectangles, that's x by 1. That's just length times width, which is just going to be equal to x. And it looks like there's 1, 2, 3, 4 of those. So I can times that by 4. So the little rectangular photos is a total area of 4x. The 2 squares, well, if I did the 2 squares, that's x by x, which is x squared, and there's 2 of them. So that'd be 2x squared. So the total areas, when I add those 2 values together, I'm going to get 2x squared plus 4x. Now, what I want to do is I'm going to erase some of this, rearrange it, because then I want to add a second part to this problem. So I'm going to arrange some stuff here. And then when I do that, we'll be able to talk about what we're going to add to it. So when I go ahead, and so if we know the total area, I'm just going to erase all this. There we go. So there's a total area of these photos. It's 2x squared plus 4x. Now what I want to do is I want to rearrange these photos so that they're a little bit closer together and figure out what the side lengths can be if I were to rearrange these. Okay, so if I were to rearrange these, and let's say I rearranged them where I had, I don't know, a square photo, and then I had our 2 rectangles, and maybe another 2 rectangles. So we're just kind of rearranging them a little bit so that's a nice little layout for the brochure, like so. What I want to know is if my total area is 2x squared plus 4x, I want to use the greatest common factor in order to figure out what are the side lengths here with this possible arrangement. So if we look, we know that these photos are x by by x, and this is just 1, 1, 1, 1. Okay, so really what I have here is if I were to just add up this side length, this is going to be x plus 2, and this is just 2x. What I did is I just said x plus x is 2x. And then x plus 1, this makes up this whole side length, is x plus 2. So if I wanted to, I could rearrange them like so, where I have 2x, and then I have x plus 2. Well, if I look here, if those are my two side lengths, that is factored out from the total area. What I could have done is I could have said, hey, I want to take out the greatest common factor and factor it out from my total area here. Well, 2x is the greatest common factor, which would then give me an arrangement like so, where I have x plus 1, x plus x, and this gives me this, where my possible height would be 2x and my possible width would be x plus 2. So it's just a different way of using the greatest common factor to rearrange some photos for a brochure, and then going from there. That's all I got for you guys. If you need any help, let me know. We're not going to do anything for things to remember. Independent practice, give me your greatest common factor, factor it out, and that's it. Greedy is out.